So in this video, we are going to be solving this problem on bisection method. The question says, find the root of the equation x cubed minus x minus 1 equal to 0, correct to two decimal places, and we are to use the bisection method. So the first thing to do is to write out our functional equation. That simply means that f of x is going to be equal to the function given to us, x cubed minus x minus 1, and that is going to be equal to 0. Now what we need is an interval. We need an interval that is symbolized. Our interval is a comma b. Now how do we get a and b? A is a value that when we plug into this equation, it converts this function directly to negative. And then b is a value that when we plug into this equation or into this function, it turns it directly into positive. But the nature in which this is done is that whenever we choose these values and plug into this equation, it must turn the equation from negative directly into positive or from positive directly into negative. Now this is what it means. We are going to be assuming values and plugging these values into this equation and observe the nature of the sign, if it is positive or it is negative. So we consider, we take our range from 0, 1, 2, 3, and so on. So we consider when x is 0, when x equals 0, we have that f of 0. This means anywhere you see x in this equation, plug in the value as 0. This is going to be 0 to the power of 3 minus 0 minus 1. And this is going to give us negative 1. Now this value is negative and it is less than 0. It is negative and it is less than 0. So we consider when x is equal to 1. We find f of 1. This is now going to be 1 to the power of 3 minus 1 minus 1. Now 1 to the power of 3 is 1. 1 minus 1 is 0. So I have 0 minus 1, which once again gives us negative 1. And this is negative and it is less than what? 0. So like I said, these values that we are plugging into this equation must convert this equation directly from negative into positive or from positive into negative before we say that a root exists between that point. Then we can bisect. So since we have negative, then we try again. Now we consider when x is equal to 2. So our f of 2 becomes, this is 2 to the power of 3 minus 1 minus 1. And this will give us 2 to the power of 3 is 8. 8 minus 1 is 7. 7 minus 1 is 6. So this is positive. 6 is positive and it is greater than 0. So since now we have a value that when we plugged in x as 1, the function changed from negative directly into positive when we considered x to be equal to 2. This now implies, remember I said earlier that a is a value that causes the function to change into negative and b is a value that causes the function to change into positive. So this means that from here my a is going to be equal to 1, since 1 causes this function to be negative. A is 1, comma, b is actually 2, the value that turns the function to positive. So b is 2. So this is now my interval, and with my interval I can find my initial guess. Now initial guess is the value to which we start our iteration. So initial guess, the initial guess is given simply as x naught equals a plus b divided by 2. So this is equal to a is 1 plus b is 2 divided by 2. So this simply implies that my initial guess x naught becomes 3 all over 2, which is 1.5. So we begin our equation when x is 1.5. So we start the first iteration. Now we consider f of x naught, where x naught is our initial guess. So this simply means now we are going to plug the value of x naught into this function or into the equation and observe the value if it is going to be positive or it is going to be negative. So let's do that and see. If we do this, we are going to have the value to be equal to, this is x cubed. X now is 1.5 to the power of 3 minus 1.5 minus 1. So let's punch this all together and see what we are going to obtain. So everything here simply gives us equals 0.875. Now this is positive and it is greater than 0. So since this is positive, remember any value that causes this function to be positive is automatically taken as b. So this now means that b is equal to what? 1.5. The value that causes the function to be positive. So b is equal to 1.5. So we have now a new interval. Our new interval becomes, okay, our new interval becomes, remember, a comma b. So this is going to be a remains a. It doesn't change. What changed now was b. So we had a new value that caused the function to be positive. So our a remains as 1. A is 1 and b is now 1.5. So what this means now is that the root lies between 1 and 1.5. So we simply bisect 1 and 1.5 to find our next iterative value. So that is going to be s1. So we find x1. x1 remains a plus b divided by 2. Still the same formula. Now this is going to be equal to a is 1 plus b is 1.5 divided by 2. So we have our x1 to be equal to, let's simply get 1 plus 1.5 divided by 2. So that simply gives us 1.25. We have x1 to be 1.25. Okay, so if we have x1 to be 1.25, we perform the second iteration. Now we are using the value of 1.25 to perform the second iteration. So we call that f of x1, and that's equal to, so in place of x in the function, plug in the value of x1. So we have 1.25 to the power of 3 minus x, which is 1.25 minus 1. So let's see what this value gives to us. So that value gives us negative 0.2969. So we are going to be approximating to 4 decimal place. 2969. Okay. Now, since it is negative, recall it is negative and it is less than 0. Remember, any value that causes the function to be negative automatically becomes a. So this means a is equal to 1.25. Therefore, a equals 1.25. So we have a new interval now. So our new interval becomes new interval, which is a comma b, is now equal to a is now 1.25. Now b remains 1.5. Okay, so now we find our next iterative value, which is x2. x2 is going to also be a plus b divided by 2, and that's simply equal to, okay, so we find a plus b. A is 1.25 plus b is 1.5 divided by 2. This simply implies x2 is going to be equal to, so let's see what that value gives us. So that simply gives us 1.375. So that becomes the next value for our iteration. So now we perform the third iteration. Okay, so that becomes now f of x2. So we simply plug in the value of x2 into the function. Once again, I have x cubed, which is 1.375 to the power of 3 minus 1.375 minus 1. Let's check this out and see what we obtain. So correct to 4 decimal places, this gives us 0.2246. 0.2246. Now, once again, this is positive and it is greater than 0. So remember I said any value that causes the function to be positive automatically becomes b. So we have a new value for b. Therefore, b is equal to 1.375. So if we have b, it means now that we have a new interval. So our new interval becomes a comma b, which is, now a remains 1.25, but now b is 1.375. So with this, we can now find our next iterative value, which is x3. x3 is a plus b divided by 2, which equals a is 1.25, 1.25 plus b is 1.375 divided by 2. So this simply implies that x3 is going to be equal to, so let's find that ratio. So that simply gives us 1.3125 for x3. So having found x3, now we perform the fourth iteration. Okay, so we perform the fourth iteration. So this becomes f of x4. F of x3. So we simply plug in the value of x3 into the equation. x3 there give us 1.3125. So we have 1.3125 to the power of 3 minus 1.3125 minus 1. So let's see what this value gives to us. So that value gives us negative 0.0515. 0.0515. Now this value is negative and it is less than 0. So when it is negative, remember, it means that a is the value that causes the function to be negative. So this means now that we have a new value for a, and a is simply 1.3125. So a equals 1.3125. So if we know that for the value of a, so we have now a new interval. Our new interval becomes, the new interval now becomes, in place of a, 1.3125, whereas b still remains the previous interval, previous value, which is 1.375. 1.375. So with this now, we find our next iterative value, which is x4. So find x4, and x4 is a plus b divided by 2, which is 1.3125. 3125 plus b, 1.375 divides by 2. So x4 is going to be, so let's find this ratio. So that gives us 1.3438 approximately. 1.3438 approximately. We are taking correct to 4 decimal place. Okay, so x4 is 1.3438. So if you have this now, you perform the next iteration. So that's going to be the fifth iteration. So please, you can compare at this point. We can compare the previous roots. The previous root is x3, and we had x3. Where is it? Okay, we had x3 here to be 1.3125. Yeah, this is 1.34. So which means the root has not converged. Remember, they said we should find the root correct to 2 decimal place. So correct to 2 decimal place simply means after the decimal points, the two numbers should converge or should be the same. So the previously we have 1.31 and now we have 1.34. It means the root has not converged. So we continue with the iteration. Now we'll perform the fifth iteration. So fifth iteration. So this becomes now f of x4. Simply plugging the value of x4 into the equation. So we have the value here, okay, is 1.3438. So we have 1.3438 to the power of 3 minus 1.3438 minus 1. So let's see what this gives us. So this gives us 0.0828, and this value is positive and it is greater than 0. So if it is positive, it simply implies, this simply implies that b is equal to what? B is equal to 1.3. 3438. The value that causes the function to be positive becomes b. So 3438. So if we have this, it means now that the new interval, okay, new interval, the new interval becomes a, which is a remains 1.3125, 1.3125. B now is 1.3438. So you have 1.3438. So with this now, we can find our next point of iteration, which is x5. X5 is now equal to, so we sum these two and divide by 2. We sum the two of them and divide by 2. 1.3125 plus 1.3438 divides by 2. So that gives us 1.3282 approximately. So x5 is 1.3282 approximately. So if we've gotten x5, we compare. So this is 1.32. Meanwhile, previously we had 1.34. So it means it has not converged yet, correct, to 2 decimal place. So we'll continue with our iteration. So now we proceed with the 6th iteration. That becomes f of x5. And that's equal to x5 give us 1.3282. So we have x cubed, which is 1.3282 to the power of 3 minus 1.3282 minus 1. So let's see what this value gives to us. So that gives us approximately 0.04, sorry, 0.01490. Sorry, 0.0149. Okay, yeah. Now this value is positive and it is greater than 0. So this simply implies that I have a new value for b. B now is the value that causes this function to be positive, and that value is from here 1.3282. So b is simply 1.3282. So this simply means that my new interval is a still remains 1.3125. Now b is 1.3282. 1.3282. So now we find the next iterative value, which is x6. Okay, which is x6. And x6 is to sum these two and divide by 2. So let's simply sum 1.3125 plus 1.3282 divides by 2. That gives us 1.320 for approximately. X4 is 1.3204. And if you compare X4 with X5, if you compare X6, I mean to say, with X5, you see that correct to 2 decimal place, the root has converged 1.32, 1.32. So this simply means that correct to 2 decimal place, the root of the equation, the root of that equation, x is equal to 1.32. Correct to 2 decimal places. So that becomes the final answer for that given question. All right, guys, so that's how to employ the bisection method to tackle that problem. I will see you in the next video with more amazing problems on bisection method. Meanwhile, look at the comment section of this video and you'll find other links to bisection videos that I've made. I'm sure you're going to find it very interesting and helpful. Thank you.